cloud formation, when you're looking at the atmosphere, there's two ways to heat the atmosphere. And there's sensible heating, which is these for conduction. Basically, the sunshine will hit the ground will absorb it, it'll make the air warmer that touches the ground, and then the air will start to rise, and that'll set up the whole process for air rising. You typically see that a lot more in the summertime when you've got a lot more intense heating going on. But I mean, it can happen, and it can make some important clouds that happen in the afternoon, or even thunderstorms too. Like some thunderstorms in the summertime are sensible heating induced, where it's just, you start in the morning, it's absolutely clear skies. By the time you get to the afternoon, you've got clouds. The clouds start to get really tall, the cumulonimbus type, and then eventually precipitation will fall out of them if there's enough moisture available. The main way that we make clouds and heat the atmosphere is through latent heating, which is the deposit or loss of heat because of the phase change of water. So going from like evaporation to condensation, precipitation, all those where you're actually changing it from one state to another. So you're going from, you know, water to a solid, or a solid to the water stage. That releases or stores, depending on what you're looking at, lots of energy. Either releases a lot of energy or will store a lot of energy. So that's probably the main way that we end up heating the atmosphere. When you're looking at cloud development, you need to have moisture, you need to have lift, so the air rising, which is that whole ways to heat the atmosphere to get it done. And you need what they call cloud condensation nuclei. So the first one, you need moisture, so moisture has to be present. Then you also need to have something to force the air to rise, and that can be what they call forced convection or free convection. Free convection goes back to that sensible heating where you're heating the surface by the sun, it strikes the surface and heats it up, or you get cold air moving over a warm surface. Both of those are what we call an unstable process. So you're going to end up with clouds and maybe precipitation out of that because it's a very unstable process. Forced convection is where something is going to make the air rise. It's not going to be a natural process because the sun just strikes the ground and heats it up. Forced would be like what they call orographic uplift, and that has to do with a mountain effect. So you have air moving towards a mountain, it strikes the mountain, it can't go through, wind can't go through the mountain, and it can't go in the ground, so it's going to have to go up. So you force the air to rise. Same thing with the front. Frontal positions move across, it will force the air to rise. Convergence is a process where you have two winds coming together, and where they meet, again, they don't just dissipate, they have to go somewhere, and then you can't go in the ground, so it has to go up. And convergence, the best example for that one is probably the state of Florida, where it has winds that come off the Gulf of Mexico and it has winds that come off of the Atlantic Ocean, and they typically meet somewhere in the middle of the state, and so that's why they get a lot of thunderstorms away from the coastline, because they've got these two winds that are coming together. That's probably the best example that there is Florida. Not that that's the only way it can happen, but that's probably the best one to think about. But once you have the moisture and once you have the lift, then you need something for that water to condense onto. If you don't have cloud condensation nuclei, so basically something for the water to condense onto, you're not going to get a cloud. You would have to have relative humidity of like 110%, which isn't possible to get a cloud. We obviously know we get clouds, so we know we have this cloud condensation nuclei. It's been around forever, it's nothing new, it's not like it's, you know, horrible to have. You actually need it. It's dust, smoke, clay particles, salt particles. I mean, it's a whole bunch of, you know, stuff. Yeah, there is, in some cases, like ash from a volcano, which isn't exactly great, but it will act as condensation nuclei. So it's always going to be present. There's always something in the atmosphere for the water to condense onto. But once you have those three ingredients, then boom, you can get yourself some clouds. Depending on how much moisture you have, how much lift you've got, depending on what kind of clouds you're talking about. If you have very little moisture in the upper part of the atmosphere, then you're going to get more of those thin, high-level clouds. Versus if you've got a lot of low-level moisture that's, you know, liquid form, you're going to get a lot more stronger uplift. You can get more of those, you know, cumulus to cumulonimbus type clouds. The next part, when you're looking at cloud formation is what they call the adiabatic process. The adiabatic process, and your lab actually goes through this a lot too. What you're doing with the bottle actually demonstrates this, pretty well. But you have what's called compressional warming and expansional cooling. When you have air particles that are rising to form a cloud, as you go up in the atmosphere, the pressure, gets less and less. It's more pressure at the surface because that's the weight of the atmosphere. As you go up, the pressure decreases, so your air molecule will start to expand because it will fill the container that it has. And if you're giving it more space because the air pressure is going down, then your parcel is going to expand. That expansion makes it cool, which can also help in the process to form clouds because you want the air to cool in order to condense the water out of it. So that's kind of how that happens, is as you go up in the atmosphere, the pressure decreases, thus the particle expands. It's a cooling process, and it allows the water to go from the gas state to the liquid state to condense onto the cloud condensation nuclei. Same thing in that adiabatic process. If you have an air parcel sinking, going down to the ground, it's going from having a lot more space, getting more air pressure, it's going to shrink it down, and it's going to compress it. And if you compress something, you heat it up. So you're going to have sinking air, and you're going to end up warming up the air in the process. This can best be seen on mountains, like the whole orographic effect, where you have on one side it's going to be much cooler conditions, and on the other side it's going to be much warmer and drier conditions. Because if you're on what they call the windward side, you have air striking the mountain, the air is forced upwards, so it's rising, and it will cool, it will form clouds and possibly even precipitation. As that air makes it over the other side of the mountain, it's sinking back down, you're compressing it, so you are heating it up, which means you're separating it from the dew point, so you're drying the air out. And on the other side you can have much warmer conditions. In the Kansas City area, we can get that a lot, they call the Chinook wind, where it's coming over the Rocky Mountains and it's going downslope, and it ends up heating it up, and we can go from one day being in the 30s to the next day being in the 50s and 60s because we have the Chinook wind has moved across. It's much more exaggerated effect if you look closer to the mountains, but it can affect us here in the Casey area as well. So when you're looking at this process of whether it's going to be what they call stability, so is it a stable process or an unstable process? So if your air is rising, going up, then you're going to have unstable air because it's going to be able to form clouds and possibly precipitation. If your air is sinking, so it's going down, you have that compressional warming take place, then you have what's called stable air, when you're not going to have clouds form from that. If air is sinking, clouds can't form. When they call like either a neutral or a conditional stability, then that means that the air parcel itself isn't necessarily going to rise or fall, but it could do one or the other depending on what's happening. So if you have a neutral air parcel, what they call conditionally stable, you can easily force it the other direction. So whether that be making the air rise or making the air sink. So that can be a good way for clouds to form or have a storm system, is if you have either neutral air or unstable air as well.